Okay, I am Dr. Janet Bastiman. I'm Chief Data Scientist at a company called Napier AI, and we do data science and AI solutions to prevent and detect any forms of financial crime. I'm also chair of the Data Science and AI section of the Royal Statistical Society, and I sit on the Financial Conduct Authority's synthetic data expert group as well. So initially I didn't. At school, being very good at maths and sciences in general, sort of towards the end of the 90s, everyone was going into maths and computing, and I just wanted to do something different. So I went into biochemistry and understanding neurons and things like that. When I came out of that, I then went into my PhD, which ended up being a little bit more theoretical than I originally intended, and I was doing models of neurons in the computer, so very early actual biologically inspired neural networks at the turn of the century. And then when I came out of that, I think the industry wasn't quite ready for the explosion, because I think we were about 10, 15 years too early for the computing power. So fell into sort of standard computing, solved a lot of problems in big data. And then when industry started picking up on sort of data science and AI-based practices, I joined a few startups, started moving things forward. And over the past sort of decade and a half, I've got to where I am now, sort of running teams doing data science and AI. I mean, it starts back as a kid. Sort of, I was always one of those kids that loved problem solving. So I'd have little puzzle books all the time. Loved maths. Anything that was problem solving and looking at data, all those sorts of things, I was absolutely enamored with. And even when I wasn't doing that sort of thing as a career, I was always looking for those sorts of things. So, I mean, starting off with some of the mobile telecoms work that I did sort of in the early 2000s, trying to do things in a very optimized and precise way by solving those sorts of data problems and working out what you could optimize. And then with larger data, as that became more of a thing, really structuring and looking at the relationships in data. So that path, it was fairly organic, and I fell into it before I really knew it as data science. And then when I started working for the startups, particularly as sort of machine learning practitioner and a CTO, sort of looking at the AI solutions, I had all of those skills that I'd built up over quite a few decades by that point to take what was quite a fast-paced and emerging industry and apply it to lots of different problems. So for me, looking at whether it's sort of a financial crime problem or a marketing problem or an engineering problem, it's those sort of same skills that are the thread through it all that I've kept. So it wasn't an intentional path, but it was a path based on curiosity and technical problem solving. Gosh, it's a really tricky one. I mean, I hate having to hedge when there's like two things in my head. So I think from a practitioner point of view, some of the models I've done in the past 5 years while at Napier, we've had a few that have directly led to some of our clients picking up what looks like sort of quite severe financial crime activity very, very quickly. So even in the initial onboarding phases, we've been able to spot things. And that's really nice to see models that you've spent ages agonizing over getting right and making sure that they're ethical and they've got all the explainable aspects to it, actually working in the real world to solve really quite big problems. So that's sort of a general practitioner one. But I think in terms of sort of general proudness, I think it's some of the education pieces I do, because I'm a guide leader as well. So I talk a lot to guides, so 10 to 14-year-old girls, about the way things are going and educating them on some of the dangers of AI and the world that they're growing up in. And I think that for me is sort of a, I mean, not practitioner-y, but is equally proud moment. I would say, as a chief data scientist, no 2 days are the same. I could be sort of, if I kind of average a day based on what I'm doing over a month, I'll spend a bit of time speaking to clients, talking to them about what they can do with various AI solutions, particularly in light of what's changing quite rapidly in terms of global regulations on data privacy and AI. So making sure that they're aware of that and looking at their use cases, and corresponding activities. So sort of requests for proposal information, sort of talking about what our products do. I also spend time with my team, supporting them almost in sort of a lab style way, because they're doing research. So we'll talk a lot about what they're researching and ideas for what they can look at next. I'll look at potentially maybe a little bit of coding myself, although that's becoming less and less at the moment, which is a bit of a shame, but sometimes it's nice to create a prototype, even if someone else in the team then takes it forward. I'll probably spend a little bit of time keeping an eye on latest research myself, just to make sure that we're not missing anything. And then also just talking more widely with the rest of the company. So I do education pieces on what AI is, as well as looking at what their ideas are for what we should be building into the roadmap as well. I think there's a couple of things. I think one is education, because there's obviously a big explosion in the media of around AI and what it can do, and it's been made very, very accessible, but there's a lack of understanding of how it works under the hood. And we've been used to computers as calculators and giving the right answer and it being very deterministic every step of the way. And now we've introduced all of these probabilistic techniques and solutions, which are very, very powerful. But a lot of the time, people aren't understanding the essence of sort of that statistical uncertainty around it, and are taking it as 100% fact and unquestionable. So having that as an education piece, both within business and more generally, is quite a challenge. But then you layer on top of that regulations around what different businesses can and can't do with AI are very varied worldwide. So UK, obviously, we're looking at industry by industry and sort of sector specific guidance. But then if you're also dealing with companies or clients based in the broader EU, you have the AI Act, which is based on risk. And then as you start dealing with people, either the companies or where their customers are based broadly worldwide, you've got variations. So what might be permissible in one country and region is not necessarily in another. And that, as soon as you start growing as a business and as a data science practitioner, you've got to take that into account, and it can be difficult to keep on top of all of that unless you've got someone dedicated to it in your company. I think it could go one of two ways. Obviously, we've still got this explosion in performance in terms of what the models can do and the power that's needed to support those. We're starting to see, and I'm really pleased to see it, more efficient computing. So really looking at those models, and rather doing the lazy, let's just throw more RAM at it, let's just throw more data at it, really pulling those apart to make them more efficient and effective, which is great. So that, I mean, for me, I think my biggest fear would be that everything becomes dependent on a handful of big corporations, and there's no room for innovation with smaller companies. And the only way that we can keep innovation going is if we have systems and processes in place for those smaller companies to grow, which needs more efficient computing. So I think that's something that I would hope would come, that breakthrough in really decreasing the power and the capacity that's needed to run these models. Because if we don't, then it's going to become too much of a monopoly for a few big companies. And I think coinciding with that, we'll see more defined legislation. And I hope that the legislation will be based on the outcomes of the models rather than too much technical detail, because it's evolving so fast that as soon as you define a model size or parameters or amount of data or anything else, then by the time that legislation's passed, that those metrics are irrelevant. So I think that's where we're going into. It's going to be a little bit of a difficult time, but that's pretty much what's going to happen, I think. There's definitely the aspect of you need to have good technical skills. You need to understand the mathematics, the statistics of it, and you need to be able to do the coding side of it. If you don't have that underpinning of the statistics and mathematics, then it's not really data science. You're probably being, an ML engineer, which is fine, but that's a different career path. You also need to make sure that you're really stoking your curiosity and your capability for broader problem solving, because without that you can get stuck. So make sure that you're not just narrowly looking at your own industry and what's going on there. Make sure that you're aware of things that people are doing in different areas so that you can see if they apply to what you're doing. And as long as you've got that really good sort of almost philosophical approach to how you're doing things, then even as the industry changes, which it will, because being a data scientist now compared to 5 years ago, compared to 10 years ago, not only have job titles changed, even though the job itself may have stayed the same, but the way in which we do things is very, very different. So you've got some jobs that are maybe called data scientists now that would have been called something else, and you equally have a variation across data science that could be lots of different things. So as someone starting out in your career, you need to be prepared for that change, and that a job title doesn't necessarily mean one thing, and look at what inspires you and what excites you and make sure that you're keeping those skills active rather than thinking I must be doing X, Y, and Z in order to get this career pathway. The underlying mathematics is very much undervalued. It's very easy to look at various online courses. There's whole loads out there that show how easy it is to build models, and it's almost sort of that, take a model off the shelf. This is the sort of model you need for this sort of problem. Stick in your data, churn a handle, out comes the result, ship it. And the problem with that is that unless you understand what the model's doing and the potential for error, you're going to miss something that's quite problematic. And one of the scariest things that we can have in statistics is where you get the right answer for the wrong reason. And particularly if you're doing your testing and your metrics look okay, but you don't understand why you've got them, and it goes out onto real world data, you can have all sorts of problems. So having that passion and underlying, say, scientific approach, and I bristle sometimes because the science part of data science, it needs the scientific method. And if you're not doing that and you've not got that understanding of how to rigorously test what you're doing, then you need someone else in that pipeline doing that, and you are not the one that's the data scientist at that point. So that, for me, that scientific process and the rigorous mathematical testing and understanding of your models is absolutely essential, and not enough people I speak to have those skills. This is really interesting. I think there's a lot of people out there who are delivering an awful lot of really exciting research work that I read. But in terms of inspiration, I really admire the people who are putting themselves out there and educating as many people as possible. So, I mean, one of the headliners here is Cassie Korskov, who used to be at Google as a chief decision scientist, and she's been creating some amazing series of videos, really getting people to think about AI and data in a different way. Someone else who I really like, who people may or may not have heard of, is a wonderful lady called Carly Taylor. And she's a data scientist and AI engineer that works in the gaming industry. So has been dealing with very, very large amounts of data. And again, she also educates people on different ways of doing things and game development and that whole industry. They're dealing with a lot of data and very critical time points because anyone who's a gamer knows that lag's a bad thing. So anything you're doing in that has to be done quickly and accurately. So again, she's doing a lot of education and just talking about hiring and different approaches to doing things in a way that's very, very accessible. Right. So from a paper point of view, there's I guess the latest one was basically a review looking at some of the changes in hardware. So we've gone from CPUs to GPUs and TPUs, and people may be aware of some of the quantum computing approaches and some of the AI that's being done in that realm. But there was a really interesting paper from Nature Communications where a team were looking at thermodynamic computing. So, really taking into account some of the statistical variations that normally computers try and correct for, because there'll be various physical processes that can throw individual bits off. But actually harnessing that to make AI training a little bit more efficient. Um, I found that really interesting. I think unless people are really into hardware, they may not, but I found that absolutely fascinating. It came out April this year, and it'll be interesting to see how that goes because it might allow us to do more efficient and more accurate models without hugely high powered and energy draining hardware.